All right, our second part of the 1.6 video is absolute value inequalities. So we've done absolute value stuff. We did absolute value equations. We just saw compound inequalities, which is going to kind of lead us into these absolute value inequalities. So just as they sound, they are inequalities that in some way involve an absolute value. So what we're going to do, I'm going to set up exactly what some of these like special ones mean. So absolute value of D is less than and then greater than. We're going to work in some negative numbers and figure out exactly what it means for these four setups, okay? Because we've got four different possibilities. We have less than a positive, less than a negative, greater than a positive, greater than a negative. So we're going to deal with, in just the simplest possible way, since there's just a simple D in the absolute value, we're going to figure out exactly what those four things mean. So absolute value of D is less than 4. Remember what that means is that the distance from 0. So just as a note, every time you see the absolute value of D, remember what that means is the distance of D from 0. Or let's say it a different way. Let's say the distance D is from 0. Okay, so what this means D's distance from 0 is less than 4 units. Okay, so I want you to picture a number line first. So we're going to set up a number line. Here's 0. This means its distance from 0 is less than 4 units. So it could be 1 unit, 2 unit, 3 units, 4 units, but no more than that. So 4 is the boundary. But remember, distance isn't just to the right. Distance could also be to the left. So we could also go 1, 2, 3, up to 4 units to the left as well. But remember, no more than that. So we can go up to 4 units to the right, but not actually hitting 4 units. And then we can go up to 4 units to the left without actually hitting 4 units. And then we could be anywhere in between. So anything that I pick in here in this shaded region has an absolute value that's less than 4. Say I pick -3, its absolute value is less than 4. +2, its absolute value is less than 4. So anything in this shaded region, its absolute value is less than 4. So what that means is that this inequality right here is the same as this inequality. You remember those 3-piece inequalities that we just saw. So that comes out to be the same as this. So anytime I see an absolute value that's a less than, I'm going to be able to rewrite it like this. It's also the same as that and compound inequality that we saw. Okay, so same idea here. This one, this is the distance from 0. It's got to be less than -4. Okay, so let's set up a number line. Okay, so 0. So -4 as a distance, that's actually not possible. I can't go -4 units in any direction when I'm talking about distance. So when it says it has to be less than -4, that's actually not possible. Less than -4 includes values like -5, -6, -7. I can't be -5, -6, -7 units away from 0 on a number line. I just can't. So this one turns out to be impossible. Not possible to do this. So whenever something's impossible, whenever it doesn't have any answers at all, we say that it has no solution. So less than a positive comes out to be this 3-piece inequality. Less than a negative turns out to be impossible. That's what I've got so far. I have 2 more to look at. I want greater than a positive. So again, we're going to start by setting up a number line. Here's 0, because anytime I see this symbol, I'm talking about the distance that D is from 0. So this says that D is at least 4 units from 0. So not 1, not 2, not 3, because that's not far enough. But 4 is possible, or 5, or 6, or 7. So it can be anywhere in here, because that's at least 4 units away from 0. And then I have an open circle, because this just tells me that I don't include the 4. And then not -1, not -2, not -3. But if I want to be at least 4 units to the left, that would include -5, -6, -7. Any of these numbers over here are also at least 4 units from 0. And again, open circle, because it doesn't have the or equal to. So that's what my actual graph would look like. That's what the picture would look like. So let's see what the inequality would look like. This piece right here, this is the same as saying that D is less than -4. And then remember, when I have 2 separate pieces like this, I do an or. Or, and then this is D is greater than +4. Okay, so that's what this turns out to be. When I have the absolute value with a greater than, it turns out to be an or inequality with the two separate pieces. Now finally this one. Okay, set up a number line. So my last one is greater than a negative. So my distance from 0 is at least -4. Now this is a weird one because absolute value, remember, always has to be positive, and a positive number is always bigger than a negative number. So if this is always positive, it's always going to be greater than a negative number. So this statement is always true. No matter what D is, no matter what you plug in for D, something that's always positive will always be bigger than -4, because all positive numbers are bigger than -4. So if that's always true, what that means my solution is here is all reals. All real numbers that you could possibly think of would make that true. So I just saw every single possibility, right? I've got less than a positive, less than a negative, greater than a positive, greater than a negative. So either no solution or all reals, these are kind of the weird ones, or I've got my more normal ones with the positive numbers, and those are the ones that we're going to be analyzing down here. Okay, so here I have greater than a positive, less than a positive. Again, we're assuming right here that C is positive. So we're going to rewrite these as a different compound inequality. Okay, so when I have greater than a positive like this, it ends up turning into a compound inequality. All right, so it's going to look like this. I could have AX plus B is greater than C, or, because remember this turned into being an or inequality, or remember what I had with my other two cases in 1-4. I had my same case and my opposite case. So here's the same case. I just keep exactly what's inside and I write it right here. Or the opposite case. Now change AX plus B to its opposite, like this. Okay, so that turns into an or inequality. And then if I do this one, the less than turns into an and inequality. Okay, so I have case 1 where it's the same, and then I have case 2 where the inside becomes opposite. Okay, so these are really, really similar to the equations. The only difference is since it's an inequality, I turn it into a compound inequality where either I have or and. So greater than turns into an or, less than turns into an and. As long as you remember that, you should be pretty much good, because the two cases are the same cases that we had in 1-4. All right, so let's look at some examples. This one right here, I've got a greater than. Okay, so I'm going to set up two cases. So I have the case that's the same, 4x minus 7 is greater than 13. And then since this is a greater than turns into an or inequality. And then I have case 2 where this becomes its opposite. So 4x becomes negative 4x, minus 7 becomes plus 7, and then greater than 13. Okay, so same, opposite, greater than turns into an or. Okay, so let's actually write that down. Greater than turns into an or, less than turns into an and. Like I said, as long as you remember that, you should be good to go. So now let's solve these inequalities. So here I'm going to add the 7 to both sides. 4x is greater than, and then 13 plus 7 is 20. Divide both sides by 4. So I end up with x is greater than, and this is a 5. Now let's solve this one. Subtract 7 from both sides. I have this negative 4x is greater than, then 13 minus 7 leaves me with 6. I can divide both sides by negative 4, and I'd be super careful here, because remember, when you divide by negatives, you flip the inequality. So this x is now by itself, but the greater than becomes a less than, and then 6 divided by negative 4 reduces down to negative 1.5. Okay, so these are my two pieces. They're separated by an or, and now I'm going to graph it. Okay, so here's 0. That would put 5, maybe around here, and then 1.5 right there. Okay, so I have greater than 5 or less than negative 1.5. So greater than 5 means I put an open circle on the 5 and I shade to the right, and then less than negative 1.5 means I put an open circle here and I shade to the left. So that would be my final answer. Okay, so anything in my shaded green region would make this inequality true, or if I tried to plug in something outside the shaded green region, it would make the inequality false. All right, last example. This one is a less than, so we turn it into an and inequality. Okay, but I still have my two cases. Case one, I set up the same, and then since it's a less than, I'm separating it by the word and, which means I'm looking for the overlap in my final answer. And then I have case two, which is the opposite. So opposite of 5z plus 2 is negative 5z minus 2, less than or equal to 17. So less than means and. Once I'm all done, I'm going to do the and compound inequality, which means the overlap between the two. So I still solve just like normal. So subtract 2 from both sides. I'm trying to get z alone. So 17 minus 2 is 15. And then to get z by itself, I'm going to divide both sides by this 5. So z is less than or equal to 3. And, which means overlap. Here I'm going to add 2. And negative 5z is less than or equal to 19. And then to get this by itself, divide both sides by negative 5. So remember, divide by a negative. I'm going to flip this now to a greater than or equal to. And then this doesn't actually reduce down at all. It's just shy of 4. So when I divide this out, 5 goes into 19 3 times, and then 4 over 5 would leave you with 0.8. Or you can do a mixed fraction or an improper fraction, whatever you're feeling, it doesn't matter. So this is an and. So and means it's going to be an overlap. So let's look at 0. Here's 3. Here's negative 3.8. So we want it to be less than or equal to 3 and greater than or equal to negative 3.8. So I start here and go to the left, and I start here and go to the right. The overlap would be what's in between those two. Okay, so the overlap would be, I've got everything that is less than or equal to the 3 and greater than or equal to the 3.8. So they end up overlapping, meeting in the middle, and then this would be your and inequality. It would be in between those two numbers. These are both shaded because these both have the less than or equal to. All right, that's it for 1-6.